And now continue with combine mechanism. Now we combine mechanism E with mechanism B. Mechanism B is just the combine between C and D, right? E is combination between C and D, the previous step. Now we combine that combination mechanism with mechanism independent mechanism B, becomes mechanism F. Okay, what is mechanism E? In the previous step we have mechanism E. Okay, so hinge at the bottom of the column and beam here and beam here. With this one we already have 700 lambda and 1200. Okay, with mechanism E. And mechanism B. With mechanism B, we have hinge at this beam at the middle and both end. And with mechanism B, we already have external work and internal work. And now we combine E and B together. This is combination between E and B mechanism. Okay, please note, please look the joint B. The joint B. In mechanism E, this rotation is plus theta. Okay, plus theta. Is this right? This rotation is plus theta. And how about here? This rotation. This rotation is at mechanism B is minus theta. Okay, minus theta. Then when we combine both mechanisms together, the two mechanisms together, then plus and minus, it's gonna be disappear. Okay, disappear. Then it means the hinge at the beam at B is disappear, is eliminated. Okay, then no hinge at all. So we have two hinge. One hinge is at E and one hinge is at B. Already eliminated. Then we have minus 2 theta. Okay, minus 2 theta. So we cancel the hinge at B because due to the cancel of hinge at B, we have to minus 2 theta multiplied by MP. MP means 200. Okay. Then now we combine the combination equation. Work equation of the combined mechanism now becomes this external work and this is external work plus equal to 1100 lambda, and this one, okay, 1200 and plus 800 and plus minus 200 equal to 1600. Okay, this must be equal. Okay, this is work equation of the mechanism F. It is combination of E and B. Then this mechanism has this equation. Okay, work equation. By solving this equation, we have lambda equal to 1.455. That is solution corresponding to mechanism F. Okay, and this is partial mechanism. Okay, we know this is partial mechanism, not full mechanism, because one more independent mechanism, mechanism A, has not been included. Okay. However, with this mechanism, combined mechanism, we have lambda equal to this. And now we combine mechanism F with mechanism A. It's become mechanism G. Okay. What is mechanism F? Previous step we have mechanism F. Okay. The hinge at the bottom of the column, the hinge at here is C and E, and the hinge at F, the hinge at the end beam at G. And with this one, mechanism F, we already have this work equation. And for mechanism A, we also have equation, work equation. Okay, already have. And now we combine the two mechanisms together, F and A. It becomes mechanism G. Okay, mechanism G. And again, here for at F mechanism, the rotation at C is plus theta, and the rotation at C corresponding to mechanism A is minus theta. Okay, minus theta. Here plus and here minus. Then the hinge at C will be cancelled. Okay, or will be eliminated. Then we have two hinge is cancelled, so we have minus 2 theta. Okay, minus 2 theta. Then due to the cancel of hinge at C, we have minus 200 and multiplied by 2 theta. Okay, then now mechanism G, the combined mechanism G. We have this work equation. Okay, we have work equation. Then lambda now equal to 1.429. This is solution corresponding to the combined mechanism G. And as you know that now G is full combined mechanism. Okay, full combined mechanism. So it means lambda, the solution here, is maybe correct mechanism. Okay, might be correct mechanism. But we have to do the moment check. Okay, moment check to ensure if this solution is correct solution or not. Okay, we have to do the moment check. Okay, so now as a result of the combined mechanism method, okay, we have the hinge at here and here and here and here and here and here. It is the G mechanism or the full combined mechanism. Okay, so we have moment here is MP and MP here. This MP here of this section. Okay, this section. MP here MP here and an MP here. How many unknown? How many unknown? We have unknown is here, MC. We don't know. We have not know. BC, okay, this column BC. BC, unknown. BA, this column, okay, this column, this section, MBA is unknown. And for this beam, MBZ is unknown, this section of the beam. And for G8 column, this section is unknown. And the last unknown is this column here, this section, okay, unknown, MGE. So we have 1, 2, 3, 4, 5, 6 unknown. 1, 2, 3, 4, 5, 6 unknown. Okay, and we have to check. We have to check all of 6 moment of 6 section. Okay. For moment check. For moment check. First, we have to determine the number of redundancies. In the previous class, I have already mentioned how to do the moment check. Okay, then first step is to determine number of redundancies. Okay, we use this equation. I equal to x minus m and plus 1. This is the number of redundancies. What is x? X is redundance of original frame. Okay, redundance in original frame. And we know x equal to 6. 6. Okay, x equal to 6. Redundance of original beam frame. How about m? How about m? M is number of plastic hinge. Number of plastic hinge. How many m? 6, of course. Okay, 6. In the previous final combined mechanism, we have m equal to 6. Then the number of redundance at collapse I equal to 1. 6 minus 6 and plus 1 equal to 1. It means we have redundance at collapse equal to 1. So we have 6 unknown, okay, 6 unknown. And 1 is redundance. Then we can select one of them, 1 of 6. Then we can select MBC. Okay, we can select MBC is redundance. So MBC here. So we have 1, 2, 3, 4, 5, 6 unknown. And 1 redundance, and we can select one of them. You can select MC or any other unknown, but in this case, we can assume the redundant is MBC. Okay, with MBC is unknown, and we already have some moment at some section. Now we have to determine the unknown MC, MBA, and MBZ, and MGH, and MGE as a function of MBC. Okay, the function of MBC. Here we go. This is final mechanism, full mechanism, final mechanism. So we do the moment check at the beam CE, beam CE. Okay, beam CE here. We already have MP at E. Here's MP, and here's MP. But MSC is unknown. Okay, MSC is unknown. We have to check MC. Then we can use beam mechanism. Beam mechanism here. It is equilibrium set for the beam CE. This is plastic hinge at A and plastic hinge at D, and MC is unknown. And we can use geometry set for the beam. Geometry set, okay? Geometry set for the beam. Here is a minor theta, and 2 theta. Okay, so we use this equilibrium set and geometry set. Then we can write down the work equation. MC multiplied by minor theta, MC multiplied by minor theta, and plus 200 here, multiplied by 2 theta, and minor plus here is minus 200 and multiply minus theta. This is internal work. How about external work? External work for here is this displacement. This displacement is 10 theta and multiply by this load 30 lambda. 30 lambda. Lambda, now we have lambda equal to 1.429 as a result of the previous step. Okay, that is a solution of previous step. And 30 lambda. It is this distance. It is external work. Okay, then we can solve this equation. We have MC. MC equal to 171.3, and compared to MP is smaller than MP, then it is satisfied. Now we have MC equal to this. Okay, and similarly we can determine the moment at the beam BG but at the joint B. Okay, so let's say here we can check the moment BG. We can use the same equilibrium set and geometry set. Okay, here is also MP and MP same, but here not MC but MBZ. Okay, so BZ. Then the geometry set is similar, same. Okay, same. Then you can write down again the work equation like this. Similar, not the same, not exactly. Okay, so here we have again MBZ multiplied by minus theta. Okay, minus theta, and multiplied by a plus 200 and 2 theta, and 200 and theta, minus and minus equal to plus. Okay, then external work equal to this one, 40 lambda multiplied by 10 theta, and we have lambda equal to 1.429. Then finally solve the equation. We have MBZ equal to 28.4. Then it is smaller than 200 and it's okay, satisfied. Then now we have MC equal to this, then MBG equal to this, and they are satisfied. The moment check. Okay, remember this one, moment here and moment in this section. Okay, now we have MBC, we have moment at this, and we have moment of BZ equal to 28.4. So we now have 1, 2, 3 more moment need to be checked. Okay, need to be checked. How to check? column BC. Column BC. Okay, column BC. As you know, this section already have MBC. We assume that is redundant MBC. We have just determined MBC already here. Then this is unknown BA. So we can use this joint, equilibrium of this joint, okay? Or no, okay, column BC. Column BC. Then column BC and column GE. We have to determine moment GE first. Okay, GE first. This is an equilibrium set for the second floor. Okay, for second floor. Equilibrium set. Here is MP. Here is MC. We already know. Here is BC, our redundance. And the unknown is MGE. And we can use this is panel mechanism. Okay, this panel mechanism. Then we write down the okay, equation, work equation. For internal work first, internal work. MBC multiplied by minus theta here, plus MC. MC is 171.3 multiplied by plus theta. Then plus minus MP at the joint E is minus 200 multiplied by minus theta. And MGE and multiply by plus theta. It is internal work. Okay, internal work. How about external work? External work is, how about this one? No vertical deflection, right, in the geometry set. So this deflection is 0. Then this one multiplied by 0 is 0. How about this one? This point is remain. Then this one multiplied by 0 is 0. Only this one. This one is don't consider in this geometry set. Okay, so only this one. 20 lambda. We already have lambda. Okay, on point something. Then 20 lambda multiplied by this distance. Okay, because column is 10 length, then we have 10 theta and multiply by 20 lambda, and we have lambda equal to external work. Okay, external work. Then here internal work equal to external work. Okay, external work. By solving this equation, what is unknown? What is unknown of this equation? MGE. Okay, because we assume it is redundant. So now all theta here can be eliminated. Okay, then we already have lambda. Lambda equal to 1.429 something in the previous step. Okay, then we can determine MGE as a function of MBC. As a function of MBC. Here, MGE equal to MBC minus 85.5. 85.5. Okay, it is MGE as a function of the redundant MBC.